Hello everyone, I'm Wala Glulu. I'm a Master Industry 4.0 student, and today I will be presenting you the Agile methodology and the Scrum framework. First, we will introduce the Agile methodology. Then, we will talk about one of the most used frameworks, which is Scrum. And lastly, we'll be talking about how to apply the Scrum framework in developing software for cyber-physical systems. So, let's start. Let's start with a definition of software. A software is a collection of instructions which we give to the computer to perform a specific task. Software are divided usually into system software that provide hardware resources to the application software. Application software are, for example, accounting software, database management system. But how a software is engineered? The process starts with several steps. Software development process is a structure imposed on the development of a software. The process is represented as a set of work phases that is applied to build a software product. First, we plan how we will be working throughout the project. Then we analyze the requirements, and we start designing the solution that will be implemented later. And then we go to testing and integration. At this step, we validate the software, and this is crucial to ensure that all the customer requirements are met. The final step is the maintenance. The software must evolve to meet changing customer needs and cope with a possible change. Let's talk about the Agile methodology, which is one of the most used approaches when it comes to software engineering development. The Agile methodology proposes alternatives to traditional software engineering processes like waterfall. Agile is an iterative approach that helps teams deliver value to their customers faster and with fewer headaches. Agile software developers use short, controllable iterations of work, called sprints. In one sprint, a full development cycle is performed. It includes analysis, design, developing, testing, and product deployment. In this way, developers release a working software solution at the end of each sprint, which is usually 2 weeks. Finally, every next sprint is an extension to the already working solution that brings developers closer to the final product. What are the biggest advantages of applying the Agile methodology? First, it's client focus. Within the Agile methodology, satisfaction is always the number one priority. With this in mind, the end users play an active role in the process. They provide feedback, which is then interpreted and acted upon by the project teams in order to improve the quality of the final project. This makes the success or failure of an Agile project measured through customers' happiness with what is produced. This means also continuously refining software and actively listening and meeting customers' expectations. The second strength of the Agile is its cost of project reduced. This is because of a lot of free work which actually doesn't get measured in the traditional way of software engineering processes. But in Agile principle, unlike the traditional process developing, in Agile we get feedback continuously from users. Therefore, we only develop the features that we're sure about, and we can guarantee that these features will be used by the client. The last advantage is the transparency. An Agile approach provides a unique opportunity for clients to be involved throughout all the project. from prioritizing features to iteration, planning, and review sessions. In the end, greater transparency increases trust, and greater degree of trust leads to a healthier customer-developer relationship. However, the Agile presents several disadvantages. One of the major weaknesses is organizational transformation. The Agile methodology requires a high level of trust and partnership. It requires business users to work collaboratively within the development team. This needs removal of some organizational barriers that make it harder to do so. Another aspect of weaknesses of the Agile methodology is the continuous pressure on the team. The regular pressure on the team during all phases of the process, which means that every sprint delivery needs developing, implementation, and testing cycle, and that puts the team at their edge of resources, and make Agile described as a non-balanced work-life methodology. And now let's have a look at Scrum. Scrum is traditionally used by teams who want to get more work done in shorter time. Teams implement iterative 2-week sprint to tackle project incrementally. Each sprint starts with sprint planning. At this stage, we create tasks lists that need to be accomplished during the sprint. Then we go forward to schedule daily Scrum meeting. Over the sprint process, daily meetings need to be held, during which the previous work is reviewed, and also the upcoming steps are discussed and roadblocks are usually identified. The last step is sprint review. This is the phase of analysis and evaluation of the work that has been done. This review lets the team make any probable change before starting new sprint. A Scrum team structure is usually composed of product owner, Scrum master, and also the developing team. The product owner is the source of information about the product. He shares his vision about the project, and he also facilitates the communication between the team members. Product owner has to identify features and requirements, but also record this in detail by creating a user flow diagram. Whereas the Scrum Master's role is essentially about management. He is responsible for facilitating a smooth sprint process. Another key player of the Scrum team is the development team. It is composed of all individuals who are responsible for creating the deliverables of the project. The development team should manage to complete a sprint within respect of time and project flow constraints. And now, let's see what challenges face the Scrum framework while implementing a software in a cyber-physical system. The first challenge is the team engagement. This is crucial for a cyber-physical system because all team members must follow the Scrum procedures. Otherwise, this will result to a more difficult information share and sometimes knowledge loss. Second, the lack of documentation. The team must adopt a time strategy for sprint development. The length of each sprint must be adapted to team's resources, but also motivation. The third big challenge is sprint length. One of the biggest challenges in Scrum is documentation management. As less process steps are documented, the risk of data loss and requirements mismatch is also frequent and is important too. I hope that you had a great idea about the Agile methodology and the Scrum framework and how can we implement the Scrum in developing software for a cyber-physical system. Thank you for your attention.